Hello, I'm Vinay Reddy, Product Manager for VMware NSX product. Today, we're going to talk about a new feature on vSphere platform, which is called vSphere with Kubernetes. This is a solution that is made up of three key building blocks that VMware has been providing for infrastructure as an infrastructure software. So the key building blocks are ESX, NSX, and storage. So what does this vSphere with Kubernetes provide for the end customer? The value of this solution is for IT ops people to enable the infrastructure for self-service. What it means is the DevOps individual can, in a self-service manner, deploy their applications or workloads of their choice. So let's look at the solution from infrastructure or IT ops perspective. See, the IT ops individual first sets up the SDDC and then turns on vSphere with Kubernetes capabilities on vSphere cluster by cluster basis. So when an IT ops individual turns on this capability on a vSphere cluster, it is termed as supervisor cluster. So in this example, the IT ops individual has set up cluster 1 and supervisor cluster 2. The next thing the IT ops individual would do is carve out an isolated space on top of supervisor cluster to enable the DevOps individuals to deploy their applications. These are termed as namespaces. So in this diagram, you would see an IT ops individual deploy or create namespaces for dev environment, for test environment, and for production environment. Now, once IT ops sets up this infrastructure, now in a self-service fashion, the DevOps individual can access this infrastructure and deploy their applications or workloads of their choice. And the key workloads that you can deploy on this infrastructure, one is pods, right? So here, the DevOps individual is deploying 2 pods, let's say, on namespace dev. And then in the test environment or test namespace, the DevOps individual can deploy another kind of workload, what we call as Tanzu Kubernetes cluster. What this does is enables the DevOps individual to deploy a Kubernetes cluster on top of the supervisor clusters. So this Tanzu Kubernetes cluster will be made up of multiple master nodes and worker nodes, which are all made up of VMs with their own distribution of Kubernetes. And from VMware, it's referred to as Tanzu Kubernetes cluster. So this is the self-service model that enables the DevOps individual to deploy the workloads in a self-service manner on top of the supervisor cluster. So this is the solution. Now, the rest of the talk is around how networking and security is provided to these workloads. Okay, now that you have seen the key building blocks that make up vSphere with Kubernetes, let's dive into networking aspect and how NSX provides all the networking capabilities for vSphere with Kubernetes. Now, as you see, there are 2 personas that is driving this vSphere with Kubernetes infrastructure. The first is IT ops, the second persona is DevOps. First thing what IT ops would do from an infrastructure perspective is they would set up their infrastructure with key SDDC building blocks, that is vSphere, which with all the ESXi hosts, create a cluster, a vCenter is deployed, and an NSX is deployed. Now, as part of deploying NSX, IT ops would also deploy key pieces of infrastructure that NSX would require. That is a pair of edge gateways or a cluster of edge gateways. All it does is it provides a service to connect to outside world physical network to these clusters that are within the data center. Now, let's look at the workflow and see what happens behind the scenes from a networking perspective. So IT ops persona would come and create a supervisor cluster which enables vSphere with Kubernetes feature on that vSphere cluster. When he enables that, that vSphere cluster would turn up into supervisor cluster. And then the IT ops persona would create a namespace on that supervisor cluster. Before we set up namespace, let's walk through what happens from a networking perspective. As the IT ops persona enabled this capability of vSphere with Kubernetes on this cluster, supervisor cluster, NSX would set up a T0 and another gateway called Tier 1 gateway just for this supervisor cluster. All it does is it acts like a two-tier routing and taking all the traffic that comes in from all the workloads and transfers it or passes it or routes it through T0 to the physical network. The next thing, let's look at what IT ops does, is creates a namespace. So here, let's say IT ops person creates two namespaces. Let's say namespace dev and namespace test. So as soon as the IT ops persona creates these two namespaces, behind the scene, from a networking perspective, NSX would create two logical segments for these namespaces. And it also allocates the subnet for this logical segment so that any endpoints that connect to this logical segment gets an IP address from this subnet. After this is done, IT ops person would now allow DevOps person to go and deploy his application. So DevOps person would interact with K8's API that is exposed as part of supervisor cluster and deploys, let's say, a service which is made up of two Nginx pods and deploys it in namespace dev. So here, I would go and represent this as two pods that are pod 1 and pod 2. So now these two pods are made up of one microservice that's, let's say, referred to as front end. Now what happens behind the scenes as these pods are brought up and connected to the network, NSX provides IP address to these pods, the first thing, right? So that they have identity in the network and they can communicate with other IP endpoints. The next thing that the DevOps person would do is, hey, this is a front-end service or it's one of the microservices. I want to have it interact with other microservice within the namespace. So that means the DevOps person should create another service of type cluster IP. So the moment he deploys a service of type cluster IP, NSX behind the scenes would go and create a load balancer for this service. And this is what we refer to as distributed load balancing. It is realized inside of this supervisor cluster. This provides for a way to expose this application within the namespace for other microservices to interact and discover this microservice. So the next thing that the DevOps person might want to do is expose, since this microservice is front end, he wants to publish this application to outside world. He would now deploy an application with type load balancer. The moment that is done, NSX would now go and deploy a load balancer on this tier 1 for this supervisor cluster and create a virtual server with virtual IP so that traffic can be addressed for this application that is exposed as type load balancer. So this is a way to publish the application to outside world. The next piece that the DevOps, next feature that the DevOps individual might want to apply to his service is who can he or she allow the traffic to, which application can interact with this application, which application should be blocked. So as part of defining the network policy, DevOps individual might apply a firewall or a network policy to this microservice. Now this is realized via distributed firewalling by NSX. So that provides security for this microservice. The last feature is, let's say this microservice, as I mentioned, was an Nginx application and it needs to pull a patch from outside world, somewhere outside. So this pod needs to interact with the outside entity to pull the patch. Now, when the traffic leaves, might have to NAT this IP address because the IP address of these pods are private, non-routable. So the other capability is the NAT capability that is provided by NSX automatically for this namespace, or any entity that is traversing through this tier 1 gets NATed out to the outside world. So net, the key capabilities NSX provides: 1, it builds a topology, a prescribed topology, routing topology to segment the traffic. 2nd, it provides distributed load balancing for exposing the applications within the namespace, what we call as cluster IP, or what is it referred to as cluster IP in Kubernetes. The 3rd is exposing this application or publishing this application to outside world via north-south load balancing. 4th, anytime the traffic needs to go out, it gets NATed. And the 5th is the security feature that is realized via network policy and what we refer to as distributed firewalling on the NSX. So net, these are the 5 key capabilities that NSX provides for vSphere with Kubernetes solution. Thank you for watching.